So percent yield, the last topic. You do this stuff every day, and the way that you do it is you utilize percent yield calculations by calculating your grade on a test. So if the test is worth 40 points and you score 36, how do you find out what you made? 36 divided by 40. If it's a 100-point test and you get 88 of them right, well, that's 88, right? It's a percent yield. It's how well you did on something. So in chemistry, we try to figure out how well our reaction works. I want you to think about this. Let's talk about it in terms of scores. What is the optimum, maximum score that you should get on every single test? 100. Now again, I need you to talk realistically. Don't go silly on me. That's the maximum optical. Again, here's a fancy science word. Theoretical. Yes. What does theoretical mean? In theory, you should make a what every test? A 100. Okay. However, what is an experiment? It's what you actually do performance-wise, right? So when you take a test, that is your experiment. But in chemistry, we actually have experimentation that we can do. So in a percent yield, you're trying to determine your maximum, which you can do mathematically, and then sometimes they will have to actually give you what you could have performed in an experiment. So we'll kind of go through percent yield, and we'll talk about what it is. The first thing is I want to see if you guys can do it. So see if you can do number one all by yourself. Write the equation and balance it. This is just one of those things that if you can walk out the door and know how to do that, that I'm satisfied with the basic novice level of your chemistry year. If you can do that basic, simple task. All right, so write the equation for the reaction of iron 3 phosphate. So I'm just going to kind of come in and make this simple for us. So it says iron 3. So who does that 3 belong to? It belongs to the iron. So we know that it is iron 3 plus, and phosphate is what? PO 4, 3 negative. Why is that a good thing? The charges cancel. Very good. All right. So I know I've got F, E, P. Can I come off this? Well, whatever. Fe3PO4. Okay. Plus, it says reacts with sodium sulfate. All right. What group is sodium in? It's in group 1, so it's a +1. And I'm going to write sulfate over there. What is sulfate? Very good. SO4, what'd you say? 2 negative. Thank you. All right, so come back down here, and so we should have Na2SO4. Now, simply looking at it, what type of reaction is it thus far just looking at that? It's going to be a double replacement reaction. So iron is going to swap with who? Sodium. Okay, and it's going to make iron 3 sulfate. I'm just going to go ahead and write out the formula since we've already got the charges. This was going to make it a little bit more challenging. So it's iron Fe2SO4 3, and then it says sodium phosphate. Okay, so I know this is going to be Na3PO4. If you got that right, give yourself a hand. If you got it wrong, don't. Now, is it balanced? No. I do see a 2-3-6 rule, though. So I've got 2 sodiums. I've got 3 sodiums. So I'm going to give this a 3. I'm going to give that a 2. And then what else do I need? That solves my problem, doesn't it? Okay. So your final answer should be 2, 3, 1, 2. We good with that? All right. So next question. If I perform this reaction with 25 grams of iron 3 phosphate and an excess of, now we've talked about this already, but I want to go back and hit this high point. It says an excess of sodium sulfate. What does that tell you about sodium sulfate that you can do with it mathematically and experimentally? What? It's infinite. You can ignore it, right? And I gave you another little word that if something is, what is the opposite of the excess? Limiting. Very good. So let's just come in and write, and actually, iron 3 phosphate, let's label this the LR. Hint, hint, wink, wink. I would know this Monday. If we run out of this stuff, iron 3 phosphate, what do we call this stuff? The limiting reactant. So whatever you run out of first is my limiting reactant. Okay, so hint, hint, wink, wink. Know what that means. So it says if I perform 25 grams of iron 3 phosphate, how many grams of iron 3 sulfate can I make? All right, so we're starting with 25 grams of this stuff. And what compound are we trying to go to? We're trying to go to grams of that stuff, correct? All right. So I'm going to come off of this slide, and I'm going to go to this because it's going to make it a whole lot faster. All right. So I've got 25 grams of FePO4. Now, we're going gram to gram, so how many steps do I need? 3. Gram to gram always needs 3. Now we just got to fill it in. All right. And I'm going to ask this question. I think I've still got it in here somewhere. Maybe, possibly. Yep, right there. What is the only way to convert from one compound to a totally different compound? Mole to mole. What is the problem with the unit that was given to me in the beginning? What's wrong with this unit? It's in grams. What do I have to get it into first? Moles. So I've got grams of FePO4, and I need to go to moles of FePO4. Now, I'm not going to plug any numbers in yet. I'm going to plug numbers in last, because the setup is the most important part. The numbers are always going to change, but if you can do the setup, the numbers are the easy part. So I've got my grams of FePO4 canceled. Why can I not stop right there? Because I've got 2 more steps. They asked me for grams of something totally different. All right. So even though I may not know where I'm going, but if moles of FePO4 is on top, where does it have to go? It's got to go to the bottom. So moles of FePO4. And a lot of students can get to that point and they're like, okay, I don't know what to do now. But remember, how do you go from one compound to something totally different? Mole to mole. Are you in your moles of one compound? So can you go into the moles of the other one? Yes. So this is moles. And what are we trying to get to again? No. What compound? Iron sulfate? All right. Thank you. Have you already found the mass for that thing? That's aggravating, isn't it? Okay. And again, I've actually already gotten all the masses ready for you guys on that. All right. So the last question is, why can't I stop there? I'm already in the compound I want. It asks for grams, so it's one more step. So I've got moles of Fe2SO43, and this is grams of Fe2SO43. I can guarantee you the compounds you do on the test are not that complex or complicated. Okay, Anthony, good? Okay, just want to make sure. All right, so now everything cancels, and I'm left with my desired value. Now let's go ahead and do the complicated ones first, since Sam's already got them. Where do you get grams from, first of all? Periodic table. But again, I'm solving those for you on the test, but what is the mass of FePO4? So 150.82. All right, what about the other one, the iron sulfate? Can anyone verify that? Anybody? If you didn't, that's fine. I appreciate Sam being able to be the mule and do it for me. All right, so now we've got 4 values worth of moles to deal with. Which ones will always get a 1? The ones that are with grams. Please do not mess that up. You only give it a 1 if it's always with grams. Now, where does the middle step come from? Coefficient. So let's come back over here. The coefficient for iron 3 phosphate is a 2. The coefficient for iron 3 sulfate is a 1. So it is going to be a 1 over a 2, correct? So that is going to be that value. So let's pull up our calculator and let's see what we get. We may need some help on some of these numbers. All right, so we've got 25. Cut it on first. All right, I've got 25 times 399.88 equals, divided by, I'm going to use my parentheses, 150.82 times 2, close my parentheses, and then there's my answer. Okay. But before you write all those numbers down, how many sig figs are in the given? 2. And how many? So what should your answer be? 33. Okay. 33 grams of iron 3 sulfate. We good with that? All right. So let's go on to the next part. And this is the first time you're going to see this question. So you got to do a little bit of stoichiometry before you can figure out this part. So what if, if I have 18.5 grams of iron 3 sulfate are actually made? Here is the key word that you're going to be looking for. There's also another word that you can see. So write this word down as well. Experimentally. I always have trouble with this. Is E or A? Experimentally. I always have trouble with that word. Is it A-M or E-M? Let's try that again. That helps. I'm not a good speller, and I apologize. So, basically, this is what they're saying. We're not going to go to that. So, as a matter of fact, I need you to do me a favor. Let's go back up because we did not do this right here. Somewhere in part 2, do you agree that you had 33 grams of blah, 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 blah? Here's what I need you to do. I need you to label this as the theoretical. Just circle that or write it beside it. This is your theoretical. This is your maximum output. What does maximum output mean? That is the most you can absolutely get that you are starting with. Okay? Not out. This is output. So if you did this reaction with 25 grams, the most you could possibly get, if you did this reaction perfect, would be how many grams? 33. But then read question 3. You did it, and how much did you actually get? 18.5 grams. So, in every experiment, there's going to be some source of error. And what you're trying to do, what the whole goal of the percent yield is to determine how well you did. Just like on any test, is there going to be some sort of error potentially made? Okay? And your goal was to find out, well, how well did I do? And so that's what the percent yield is. So by number 3, if you want to write this down, it may be a good idea. So what percent yield is? So percent Y is actual divided by theoretical times 100. Now, why is that times 100 important? All percentages must be multiplied by 100, right? I want to add 2 more things to it real quick. Actual Did I do it again? So there's 2 ways to get it. The actual, you actually have to physically perform or experiment. And the theoretical is you actually have to calculate it, which is what we just did. So actual over theoretical times 100. Why is that? All right, so let's look at it. So, and now I'm going to be honest with you. You guys know that sometimes I get real lazy with this stuff. So instead of me writing the word actual and theoretical, I write A over T times 100. But you have to know what those mean before you can actually do it. So the actual was 18.5 divided by 33 times 100. And this is it. This is all you have to do. That is percent yield. And what percentage did you get? 2.6, so let's go with 56%. So, if you did this experiment, did you do a really good job with it?
No.
Now, in a grade, no. However, I will tell you this, that most scientific experiments, your best maximum yield is around 75 to 80%. It's very, very, very almost impossible to get 100% yield. So if you're in the 75 to 80% range, you're doing really well. So 56 isn't awful, but it's not the best you can do. Okay? Say it again. Sure. Okay. Now, is the answer from problem number 3 reasonable? Explain. Go ahead. Okay. To determine how well that your like if we were doing a real lab with it, which we would have done had we had enough time, was to be how well did you perform the experiment. Okay. So the reason it is reasonable is because it's less than 100%. If you do this and you get if you get more than 100, is that reasonable? Then you did something wrong. You cannot get more than 100% output. There are no bonus points in a lab. Okay, that does not exist. Which is impossible.
You need to, there's better things you're going to be doing than being at school and being great.
Yes. Now this one I like. It's because you have to understand a little bit of basic algebra to figure this question out, and I like these questions. If I do this reaction with 15 grams of sodium sulfate and get a 65% yield, how many grams of sodium phosphate will I make? So here's what this is. Do you agree that they've given you, if I do this reaction with 15, do you agree that this is what you actually used? Okay, and they give you a percent. So the way this works is this is kind of like percent yield, and it's still A over T times 100. But what part do you think you're trying to use this time? Hold on a second. Let me stare at this one before I go any farther. Hang on. If I do this reaction, 15 grams sodium sulfate, get 65% yield. No, what you would actually be solving for here. We're going to omit this one. This is a little bit more difficult than I read into at the beginning, so completely omit this one. You will not have one like that. That's okay.
It's a lot of work for one problem.
It is a lot of work for one problem. All right, so these last two are a lot quicker, a lot faster. First thing I want you to do is just do number 1. Balance and tell me the type. Balance and tell me the type. That was an easy balance, wasn't it? Is that what you got? All right, so number 2. If I start this reaction with 40 grams of magnesium and excess nitric acid. So first of all, they tell you have excess nitric acid. What does that mean? It's unlimited. So who is your limiting reactant? Magnesium is the opposite of the excess. So we're just going to go ahead and label this guy the LR. It says how many grams of hydrogen gas will I produce? All right, so let's jump into this. So it's 40 grams. Now, guys, I'm gonna make this a little bit more specific. Do me a favor. In the problem, this is missing. I'm gonna add a decimal place. What will that do? Not 3. It'll take it from 1 to 2. I'm just gonna make it 40 specifically. All right, so 40 grams of magnesium. And what am I trying to get to? What's the question? The question is, I want to know how many grams of hydrogen gas will I produce. So we're going from gram to gram, so how many steps? 3. Now the reason this is a lot easier, I actually should have started with these problems because these masses are a lot smaller and a lot easier to deal with. So I've got grams of mg, and I've got to go to moles first. Now, I'm just going to ask this question. You already know this, but I just want to make sure we're on the same page. Why am I going from gram to mole first? I've got to get to moles to do my mole to mole ratio. All right, so now I've got moles of mg, and now I can go to my moles of H2. Now, one thing that I want to point out that's very important that you're catching up with. Okay, would you get this sheet? Okay. Here. Will you pass it over to her, please? The one thing that I want to point out is, in the problem, it says the word hydrogen, but look at the formula. What does it say? H2. Please be careful and make sure you catch that, because some people would want to put just the letter H, but you have to go with what the formula tells you. And why is there a 2 on that hydrogen? It's diatomic. So we've got moles of H2, and we've got grams of H2. All right. What up here definitely for sure 100% gets a 1? Nope. Moles that's with a what? Grams. So those definitely get a 1. All right. Magnesium is 24.31. Hydrogen H2 is what? 2.02. And what's your mole to mole ratio? 1 over 1. Very good. And where did I get those ones? Coefficients. Now let's look at the calculation. Should be an easy calculation. So it's 40 times 2.02 equals divided by 24.31, and gives me all those numbers. So now I want 2 significant figures. So what would it be? 3.3. Very good. Tray point tree. Now, you just calculated that number. So I want to go back and I want to show you this. If they ask about percent yield, what part is the 3.3? It is the theoretical. That is your maximum output. It's the most you can get. So beside that 3.3, you may want to go ahead and write the word theoretical. Okay, so let's come back to this. And then, down here, it says if 1.7 grams of hydrogen gas, what's the key word there? Is actually produced, what is my percent yield of hydrogen? So again, we've got percent Y equals actual divided by theoretical times 100. This thing is painstakingly slow. So 1.7 divided by 3.3 times 100. Anybody got a percent? 52%. Do you agree that this is very easy to do? Okay, very easy. All right, see if you can do the last one all by yourself. I will be nice, and I will give you the masses of both of these. Carbon dioxide is 44.01. And give me a second on the sodium hydroxide. Sam, can I see your calculator? Because I don't have mine out. I'll tell you what, just you do it. I'll tell you what to put in. 22.99 plus 16 plus 1.01. Yep, that's it. Even? That's right. Now that I've seen that, I remember that. So those are your 2 masses once you get to them. Thank you so much, Roman. No? What's wrong with it? Pause right there. The reason it says the word produce is because it's an actual product. So we're kind of working this problem backwards. If I got 25 grams of the product, how much did I have to start with? Does that make sense? Oh, never mind. They're both products. If you know one product amount, you can compare it to the other product amount because of the mole to mole ratio. Thank you, Romy. You can convert from any compound in a reaction simply by knowing the mole to mole ratio. Any compound. Robinson coming here, or am I crazy? I didn't even see you. Okay, I was like, where did she go? I saw you at the door, and I was like, okay, I'm blind. All right, my first question is it balanced? It is balanced. It's all ones, right? Anybody not get all ones? Let's look at it and see. All right, so I've got one sodium, one sodium. I've got one carbon, one carbon. I've got one hydrogen, one hydrogen. I've got 3 oxygens. This is where it kind of gets weird. And I've got 1 plus 2, which gives me 3. And what type of reaction is this? This is decomposition. Very good. All right, so we've got 25 grams of carbon dioxide. So 25 grams of CO2. And I'm going to go ahead and fill this in real quick. We've got 44.1 grams of CO2 in 1 mole. I've got, and it's all 1 to 1, right? 1 mole of CO2 to 1 mole. Hang on. NaOH. And then in 1 mole of NaOH, there are 40 even grams of NaOH. So what'd you get? How many grams? 23. All right, and then it says if 50 grams of sodium hydroxide is actually produced, what is my percent yield? And this is one of those weird things that I was talking about. This is your theoretical, right? So it should be A over T, which is 50, divided by 23, which gives you what percent? Does that make sense? No. Hey guys, do me a favor. If y'all would, and I was actually going to take you. I forgot we were on a sorting block.